Dear fellow scholars, this is a new episode with a special guest. Today we are going to see how AI is revolutionizing the way we analyze fossils and is changing paleontology forever. I think it is safe to say that the analysis of fossils is one of the most challenging tasks in all of science, because it is not easy to find a fossil in the first place, we get that. But also because once you have found it, cleaning and carefully removing the surrounding rock, which is called the matrix, is extremely time-consuming. And then, even after all that, identifying the species from the remaining fossil is not easy at all, especially if it is an unknown species or if the fossil is very young and thus very similar to other known species. But now hold on to your papers, fellow scholars, because there is something incredible happening. A recent paper has shown that AI is able to do all of these steps for us. Finding the fossil in the first place, cleaning it up, and also identifying it. Yes, really. So let's see this incredible paper together. The idea of using AI for analyzing fossils was proposed 10 years ago. However, back then this was mostly used for just identifying the species of a fossil given an image of it. Then 3 years ago we saw some incredible progress where an AI was able to find the fossil itself in a pile of rocks. This was truly amazing. However, today we are going to see a two-step improvement over that earlier work. Now here is the overall process. First, we take photos of a block of rock that may or may not contain a fossil. Then we hand draw the outlines of the fossil. You see, we humans still need to do some work, but only a little. Then the neural network takes over and does the rest. It cleans up the fossil and removes the surrounding rock. After that, the neural network identifies the species of the fossil. And finally, a human checks the results. So we see that this is a wonderful example of a human-machine collaboration, the best of both worlds. Humans do what they are good at and machines do what they are good at, and together they make a great team. So far, so good. But I am sure you are wondering why all this work is even necessary. After all, why can't we just throw the entire thing into the AI and let it do its magic? Well, unfortunately, we cannot do that. Why? Because before throwing the data into the AI, we need to clean the images a bit. We need to remove the background, crop the images, and also make sure that the images are of a suitable resolution. These steps are called pre-processing, and unfortunately these need to be done by hand. Once this is done, though, the AI can take over and do the rest. Now let's look at the key ideas in more detail. First step, finding the fossil. To this end, they use an algorithm that was also used in the previous work 2 years ago. The key idea here is that if you look at a cross-section of a block of rock, the fossil will typically appear darker than the surrounding material. This is because rock usually consists of minerals like quartz or feldspar, which are typically lighter in color. Fossils, however, often contain organic material which doesn't reflect light as much and thus appears darker. Thus, the algorithm tries to find regions which are darker than their neighbors, and this is how it finds the fossil. After this step, we get an image like this where the fossil is outlined in white and everything outside of it is black. Now comes the second step, and this is where the real improvements are made. Here we would like to remove the surrounding rock and keep only the fossil. Before throwing this into the AI, we need to do some pre-processing first. This means that we crop the images and resize them and also normalize the pixel values so that they fall between 0 and 1. For instance, after this step, we throw the data into a convolutional neural network that has been trained to do segmentation. What is that? That is basically the task of removing the background. This part is not new and has already been successfully applied to many other tasks before. Then another convolutional neural network takes over and removes the remaining rock. This part is also not new. Finally, a third neural network takes over that has been trained to identify the type of fossil. Yes, you heard it right. Not just the species of the fossil, but the actual type of it. Does this mean that the AI can tell apart a dinosaur from a fish or a mammal? Wow, that would be amazing. Let's see. First, we give it a cropped version of the fossil that we pre-processed earlier, and then we also add the results from the previous steps. With this additional information, it will be easier for the neural network to identify the type of fossil. And finally, after all of this, we get the result. So let's have a look at this together. Here we see the original photo of the fossil, and here is the ground truth, so to say the correct segmentation, and here comes the AI's result. And dear fellow scholars, I must say this is absolutely amazing. It cleaned up the fossil and removed almost all of the remaining rock perfectly. And the final identification was also correct. But wait a second. Here is the thing. You see, in the ground truth image, the skull is clearly visible, but in the AI's output it is not. Now, don't get me wrong, this is still an incredible result, but this seems to be a problem. How can we tell the AI to not only identify the species, but also to identify the key parts of the fossil? And here comes the simple solution. They simply added a new training step. After the initial training, they took the previously trained AI and retrained it with the results of this earlier fish example. And look, after this additional training step, it started to identify the key parts of the fossils as well. Amazing. Let's have a look at another example. And again, I am flabbergasted. Look, it cleaned up the fossil perfectly. Even the tiny details and the scales of the fish are visible. And again, it identified the type of the fossil correctly. And again, after some additional training, it started to identify the key parts of the fish as well. We can also see that it generalizes quite well to new types of fossils. For instance, here it was trained on a fontanelle and a mastoid, and then it was tested on a trematocyle. And look, it was still able to identify this new type of fossil correctly. They also compared their method to a popular software for cleaning up fossils. And while their method is not perfect yet, it is already better than this software, and it will likely improve with more training data. Also note that this software requires a human expert to operate it, and thus the time it needs to clean a fossil depends on the skill of the person using it. But the AI's time is independent of that. In any case, this is a true paradigm shift. Soon every paleontologist will have an AI assistant that helps them with cleaning up and identifying fossils. This will speed up their work tremendously and allow them to focus on more creative tasks. For instance, have a look at this example where they took a 3D scan of a fossil and then threw it into their AI, and look, it found the fossil, removed the surrounding rock, and also identified the species of the fossil. All this fully automatically. And note that this is still a preprint, which means that the results have not yet been peer-reviewed. And typically in a the authors also release the data and the code for their experiments so that others can check their results. So good job, fellow scholars. This is an incredible improvement over previous methods and is changing paleontology forever. What you see here is a report of this exact paper we have talked about, which was created with weights and biases. I put the link to it in the description. If you have been holding onto your papers so far, now squeeze that paper because you have earned it. Thanks for watching and for your generous support, and I'll see you next time.